Okay, these next problems we are going to, they give us the function f of x equals 2x and they tell us it is 1 to 1. We're going to find the inverse, then we're going to find the domain and range of f and then the inverse function, and then we're going to graph. And on this one you have to be sure that you graph the y equals x. That was the big problem with this last year. Everyone would graph the normal function and graph the inverse function, but they'd forget to graph this y equals x. So there should be 3 lines on all of these graphs. So let's go ahead and do this. So when we're finding our inverse function, our normal function is f of x equals 2x. So now we're going to swap our x and y. So we're going to have x equals 2y, and then we'd solve for y. And that's going to give us our inverse. And this one's really simple, so this one may not be the best example, but always start easy and go up. So our inverse is x divided by 2. And I'll put this here so y'all know the notation for it. So I'm going to highlight that too so y'all can see where this all goes together. Okay, now then they find the domain of f. So this is our original one. So I'm gonna go highlight it crazy. Give me a second. So this is our original function, and that's what they're asking for on these. And then our inverse function is orange, and that's what they're going to ask for on the next two. I tend to get confused after I find the inverse. I want to answer the questions for the inverse and not the original function first, so be sure you keep those in line. So looking at this, is there anything that, find the domain of f, is there anything that's going to make it undefined or unreal? Since it's just 2x, there is nothing, so it's all real numbers. Our range, same thing, all real numbers. And then on our inverse, we have x divided by 2. There's nothing that's going to make that one undefined or unreal, so we're all real numbers still. Now then, when we go to graph these, I don't think I have my ruler in here. So we're going to use this. First, just so you don't forget to graph it, graph y equals x. We're going to highlight that in a different color. So we're graphing this. Just remember there's 3 graphs, 3 lines going on this graph. I should say. So first I'm going to do y equals x, so that's 1 to 1. And you just have to graph 2 points on all of these, so I'd always graph the origin. I'm going to go ahead and highlight this. Now then, let's graph our normal function, 2x. So since it's 2x, that's a slope of 2, so from 0, 0, go up 2 over 1. I'm going to do that twice so my graph's prettier. But on your graphing tool, you'd only need to do 0, 0, and then 1, 2. It's not perfect, but it's close. And then I was graphing that one in purple, so let's make it purple. And then our inverse is x divided by 2. So our slope would be 1/2. And that's going to be an orange. And that would be problem 12. So 13. The function f of x equals x cubed subtract 5. First thing we're going to do is find the inverse. So we're going to have x equals y cubed subtract 5, and then we're going to solve for y. So I'd add my 5, and then we'd have to take the cubed root. So we'd have the cubed root of x plus 5 equals y. So this is our inverse. Here. Now our domain, is there any values of, and I'm going to write it right here, f of x equals x cubed subtract 5. Are there any values of x cubed subtract 5 that would be undefined or unreal? No. So that's going to be all real numbers. Our range on this one, is there anything that's going to restrict our range? No. Then here we have the cubed root of x plus 5. Since this is a cubed root and not a square root, we can't have negative numbers, so we're not going to have any in our domain that are not going to work, because if we have the cubed root of 0, it's just going to be 0, so that's okay. And then the range is still true. Now when we go to graph this one, since it's multiple choice, we have f of x equals x cubed subtract 5. If you remember our rules from chapter 3, the end of 3, and that one section in 4, you know that subtract 5 on the outside means we're going to go down 5 units. So let's find the graph that has the x cubed function down 5 units. So this one was down 1, that was up, up. This one is down 5. So let's do. And I'll draw a line there. Okay, 14. F of x equals x squared subtract 4. And then they give us right here, x is greater than or equal to 0. That's going to come in handy in a second. But first, let's find our inverse. So our original is f of x equals x squared minus 4. We're going to change that to x equals y squared subtract 4. And we're going to solve for y. So add 4. X plus 4 equals y squared. Then we take our square root of both sides. So the square root of x plus 4 equals y, and this is going to be our inverse. So I'm going to go ahead and move that here. So I have the square root of x plus 4. Find the domain of f, and f is f of x equals x squared subtract 4. But they give us this little exception right here, x is greater than or equal to 0. This is our domain. They ask for x on it, so x is greater than or equal to 0. Then our range on this one is 1 to 1. So if we put 0 into this equation, 0 squared subtract 4, our range, because if you remember, the graph of x squared is a parabola, so it's going to go down to a point and go back up. So that point where it's going to start, if we substitute 0 in for x, is going to be -4. So our range is going to be greater than or equal to -4. Now then, we're doing our inverse domain. So our inverse is the square root of x plus 4. So we can't have any negative answers coming out of this. So let's have x plus 4 is greater than or equal to 0, because we don't want any negative answers. So it can be 0 though, because 0, the square root of 0 is 0, but negative numbers are unreal, they're imaginary. So let's solve this. So we'd subtract 4. So x is greater than or equal to -4. And this is going to be our domain. Now then, on our range, if we use -4 as our bottom value and substitute it into this, -4 plus 4 would be 0. So our range is going to be y is greater than or equal to 0. And what I want you to notice on this one, you can kind of see all of them, but not really. Our domain and range of the inverse is the opposite of the domain and range of our normal function. So where our range was greater than or equal to -4, our domain on the inverse is greater than or equal to -4. Getting tongue-tied. So when we go to graph this one, let's look at our original function, x squared subtract 4. That subtract 4 tells me it's going to be moved down 4. And then they gave us this restriction in our domain that it's greater than or equal to 0. So that means we're not going to have any of those negative values. So let's look for, it's not going to be the full parabola, it's going to be half of it. And what are they going by here? Twos. So C is our graph. One more. The function f of x equals 7 divided by x. So let's write our original one over here. And let's find our inverse. So we'd change this to x equals 7 divided by y. And when we solve this, we'd multiply by y and then divide by x. So let's put that up here, 7 over x. Our inverse and our function are the same, so that's going to tell us that our graphs are going to be the same when we get to graphing this, and our domain and range are going to be the same. So here we go. If we have find the domain of f, we can't have 0 on the bottom of our function, and I'm going to rewrite it right here so we can see it. Because if we had 0 as a denominator, it would be undefined, so x cannot equal 0. Then if we remember from, it wasn't this chapter, last chapter, the numerator and the denominator, the degrees of them, we're going to recall that to be able to find our range. So if the degree of the numerator is less than the denominator, so n is less than m, we have a horizontal asymptote at y equals 0, so y cannot equal 0. And I'm going to tag this and put 5.3 on it. And then since our function and our inverse function were both 7 divided by x, they're going to have the same domain and range. And then we'll find our function that matches up with that over here. So if you remember 1 over x, the function graph of that function is similar to this one, it's going to be B. Because over here we have two graphs. Ours are the same. So it's either going to be B or D, but D is a negative reciprocal function, so we're not going to pick that one. If y'all have any questions, email me.